Hello, everybody. Uh, this this video will deal with the balloon, and let's see if I can get this centered a little better. How do I do that? All right, let's restart this thing and see if we can make this work. This is the balloon board, and there's lots of things happening on this thing. And remember, the basic thing we want to do is we want to send the balloon up possibly to 100,000 feet, and we want to radio its position back down to the ground. Well, so let's start by powering this thing up. So there's an onboard battery here, and when we fire this thing up, we close this switch, which is controlled by what we call a watchdog timer. This thing defaults closed. The battery now is power is put to this regulator, and no matter what the battery voltage is, as long as it's above 7 volts, this regulator will put out a constant 5 volts. And this job is to take the changing battery voltage and hold it at 5 volts. The watchdog timer function is to actually watchdog to make sure that the instructions in the PIC keep operating. In order to do that is that we will pulse this line right here. We need to pulse this line once every 1500 milliseconds. If that thing fails to pulse, this switch will open for about 200 milliseconds. This will remove the power, reset the PIC, and we start all over again. And it turns out that we've flown several flights, and that no matter how hard we try, we did not get this software stable enough so that it worked flawlessly, and this watchdog timer saved the mission. So now we've got the satellite, the balloon powered up. Let's start with a GPS receiver. We have an onboard GPS receiver, and it constantly puts out its position reports, and the signal actually is divided, and some go to the main board, and the other signal goes to a separate onboard terminal node controller and a transmitter that automatically transmits positions to the ground on a frequency of 144.39 megahertz. This is the national APRS system, and there's several stations on the ground that will receive this signal and feed it into the internet. So what comes in here is essentially data signals. This is an RS-232 bus right in here, and the signals come in here digitally. Ones and zeros. That converts this into tones, 1200 and 2200 tones, and this is transmitted on FM back to the ground, and this works autonomously, and it's always been pre-programmed, and so nothing has to happen. All right. So now let's assume that we want to send the GPS and other data down. We do that through this line. This is USART1 on a PIC, and in comes the data, the ones and zeros, and then again this is RS-232, comes into a TNC, which converts these ones and zeros into tones at 1200 and 2200, sends these to a 435 megahertz transmitter and receiver, and back to the ground this way. This is a full two-way path, so we can actually send commands from the ground on this receiver, and that will be an FM signal that has tones on it, 1200 and 2200 hertz. These tones, these analog tones, go into this TNC, get converted back to digital ones and zeros, and is available for the PIC on USART1. So let's go through some of these other interfaces on there. We have 3 additional inputs. We have labeled them Arduino 1, Arduino 2, and Arduino 3, and these are for additional data that comes in here. So there could be several sensors on one of these Arduinos that come in here. Now this is a very special MUX chip. Actually all this is a switch that are controlled by these 2 ports. Notice there's 4 switches here, 1, 2, 3, 4. So when we want to get data from the GPS end of the PIC, we will issue a command to close switch 4, or the 4th switch in this line, and the GPS will now send its data in here via the MUX chip to the USART. So when we want to take data from the outside world, we will close switch 1, for example, and data will flow in here and down here. Notice that these switches are mutually exclusive. In other words, when one of these are on, the rest of them are off. So when we want GPS data, we'll have to close this switch and then grab the data coming in here. When we want outside data, we will close this switch and then get data. This is a PIC, just a microcontroller. In this case, it's an 18F6722 8-bit chip. And now we have several sensors tied on this thing. One of the interfaces on this chip is called an I2C, which is a 2-wire interface, and this has got 1s and 0s on it, and one line is the clock and one line is the data. And these are full bidirectional ports. Some of the peripherals that are tied onto this thing is a real-time clock. So if we want to calculate very accurately time, we have a real-time clock. We have an internal temperature sensor right here. It's a digital sensor. It's on the board, and it's I2C, so we can measure the board temperature. And this fuel gauge measures voltages and currents on the battery, and can also measure the battery temperature if we desire. And we also bring the I2C interface out, so if we have additional devices that we want to hook on, we can put on the I2C interface. There are several other interfaces on this board. We bring out additional GIO lines here to connector J18, so we have power and ground and 6 additional interfaces that we can tie devices onto. We also have the analog devices. We actually have 6 analog devices that are tied up and appear on J14. So we can take analog devices and measure analogs, and of course the analog signals can be 0 to 5 volts in this case. So let me switch off here and move this thing down and get some more view here. Well, that's not super cool. We have some watermarks in here, and I don't know if they'll go away or not. Yeah, there they go. We have a high current horn switch in here. This thing can sync about an amp, so we can tie a horn in here. That is controlled on a GIO line, and the PIC can control this switch to ground, and this can be tied to a horn. We also have an output called a cut-down output. In addition to that, we have camera interfaces. These are optically isolated camera interfaces, so that if we want to control an optically isolated device like a camera that is noisy, we will put a high on this control line, that will light this diode. This diode will cause this transistor to become low impedance, and we'll actually have a very low impedance between 1 and 2. And we have several controls of this in here. So basically, in a nutshell, this is what's on the balloon board.